Today we are going to discuss some sections of Chapter 9. We will focus on chemical bonds and ionic compounds. Today we will learn why and how the elements join to form compounds. When molecules are formed or broken down into simple substances, new materials with new properties are produced. This type of change in matter is called chemical reaction. So we can define a chemical reaction as a change in matter in which different chemical substances are created by breaking or forming chemical bonds. Only the elements in the noble gases group occur as single atom. They are called monatomic. For example, we had helium in this case. Also, there is a diatomic molecules like oxygen and hydrogen, which occur naturally. Also, oxygen can occur as a triatomic, in which 3 oxygens join to form ozone. But how the atoms or molecules they stick together? This happens due to the chemical bonds. In a chemical bonds, the atoms or molecules gain or lose electrons through chemical reactions in order to fill the outermost shell and therefore get lower energy. When the atoms or molecules they get lower energy level, then they are also stable as noble gases are. So we can say a chemical reaction forms a chemical bond that is an attractive force that holds atoms together in a compound. In this course, we will study 2 different kinds of chemical bonds, ionic bonding and covalent bonding. Let's define what is ionic bonding. It occurs when one metal transfers an electron to another atom. For example, lithium, in order to be stable, needs to lose 1 electron, means lithium needs to transfer 1 electron. But fluorine, in order to be stable, needs to gain 1 electron. So if lithium transfers 1 electron to fluorine, lithium becomes a positive ion. If fluorine gains 1 electron, becomes a negative ion. Then the difference in electrical charge results in an attractive electrical force between positive and negative charges. And this type of ionic bonding occurs between metals and non-metals. In this case, lithium corresponds to the metal material and fluorine corresponds to the non-metal material. In this example, we had carbon and hydrogen. We can see carbon has 4 electrons in the outer shell, but hydrogen has just 1 electron in the outer shell. Carbon, in order to be stable, needs to get 4 more electrons in order to have the neon structure. In case of hydrogen, hydrogen needs to have 1 more electron in order to have the helium structure. Then what happened in this case? Then 4 hydrogens share the electrons with 1 atom of carbon. So 4 hydrogens and 1 carbon share electrons to form methane. Then the key word in the case of ionic bonding is transfer, and the key word in the case of covalent bond is share. In this course, we will focus on study the ionic bonding. Compounds that are held together by ionic bonding are called ionic compounds. We will learn how ionic compounds are forming, how to write their formulas, and how to name them. Let's see first this example. In this case, we had sodium, which is a metal, and we can see sodium has 1 electron in the outer shell. We had chlorine. Chlorine is a nonmetal, and chlorine has 7 electrons in the outer shell. Then in order to be stable, sodium needs to transfer 1 electron to chlorine. In this way, sodium will get the neon structure and chlorine we will get the argon structure. When this happens, sodium becomes a positive ion and chlorine becomes a negative ion. Then positive and negative charge they attract to form a new compound. This compound is called sodium chlorine. Sodium chlorine is just the salt we use for cooking. It's the same thing. Also, we can represent the ionic bonding or the formation of the ionic compounds using the dot notation. We can see here sodium, which has 1 electron in the outer shell. Then we can represent using 1 dot. Chlorine, which has 7 electrons in the outer shells, we can represent using 7 dots. When the ionic bonding occurs, then we will have a positive ion of sodium because sodium loses 1 electron, and we will have negative ion of chlorine because chlorine gains 1 electron. Now let's see how to write the formulas and the names of the ionic compounds. The formula of a compound describes what elements are in the compound and in what proportions. Let's see what are the rules to write the formula of an ionic compound. The symbol of the positive ion, which is the metal, is written first, followed by the symbol of the negative ion, which is the non-metal material. Subscripts are used to indicate the number of ions needed to produce an electrically neutral compound. And this is important. Always the new material or the compounds must be electrically neutral compound. Let's see what will be the formula for our previous example. In this case, calcium is the metal, is the positive ion, then this will be first in the formula. And the chlorine is the negative ion on the non-metal is the second part of the formula. Notice that in the formula we don't write the signs that indicate the charge. We don't write the positive or the negative signs here. Just we write the chemical symbol of each of the ions. Then this will be the formula for this ionic compound. Let's see how we can write the name of this compound. The rule is we will write first the name of the metal and then the name of the non-metal. But in case of the non-metal, the ending of this material will be changed by "ide". Then the name of these compounds will be sodium, and then the second part will be chloride, not chlorine. Then we need to change the chlorine by chloride. Let's see 2 more examples. In this case, we have magnesium and we have oxygen. Let's see what is the compound that resolves if magnesium reacts with oxygen. And we have magnesium. Magnesium is in the second group. This is why it has 2 electrons in the outer shell. And oxygen is in the group number 6, and this is why oxygen has 6 electrons in the outer shell. In order to be stable, magnesium needs to lose 2 electrons. In this way, magnesium will have the neon electron configuration. In case of the oxygen, oxygen needs to gain 2 electrons to get the neon electron configuration. So if magnesium loses 2 electrons, becomes a +2 ion. If oxygen loses 2 electrons, becomes a -2 ion. Then the first thing we check before to write the formula is see if the compound that results is neutral. And we can see here magnesium is +2, oxygen is -2, then it's neutral. And now we can write the formula. Then to write the formula, first we will write the symbol of the metal, which is magnesium, and then the symbol of the non-metal or the negative ion, without any sign, just the symbols. Then this will be the formula for this compound, for this ionic compound. Then let's see the name. To write the name, we will write the name of the metal, which is magnesium, then the name of the non-metal, but for the non-metal we change the ending by "ide". Then the name of the compound will be magnesium oxide, and this will be the name of this compound. Let's see the other example. In this case, we had calcium and chloride. Then we want to know what is the compound that results if calcium reacts with chlorine. And let's see what happened with calcium. Calcium is in the second group. This is why calcium has 2 electrons in the outer shell. What happened with chlorine? Chlorine is in the 7th group. This is why chlorine has 7 electrons in the outer shell. Now, what happens if these two react? If one atom of calcium reacts with one atom of chlorine, then calcium will transfer 1 electron to chlorine. In this way, chlorine will be stable because now chlorine has the electron configuration of argon. But what happened with calcium? Calcium is not stable because calcium needs to lose 2 electrons in order to be stable, in order to have the electron configuration of argon. Then this is why we need 1 more chlorine. In this way, calcium will transfer 1 electron to another atom of chlorine. Then now calcium loses 2 electrons, and this is why now calcium is positive 2 ion. And in this case, we will have 2 atoms of chlorine. Each of these atoms has -1 charge. And let's see what happened with the total charge of the new compound. And in case of the positive ion, we had +2. But in case of the negative ion, we had -1 for one chlorine, -1 for the other chlorine. Then the total negative charge will be -2. Then now we can see the new compound, the new ionic compound is neutral. Then now we can write the formula. Then to write the formula, first we write the symbol of the positive ion or the metal ion, and then we will write the symbol of the non-metal or the negative ion. Then will be calcium, CaCl, but now we need to be careful because we have 2 chlorines. Then to indicate we need 2 chlorines in the reaction or to form the new compound, then we will need to add the subscript 2 to chlorine. Then we will have, this is the formula. Calcium, then the symbol of the chlorine, and then the subscript 2. Now the name. To write the name, we will write first the name of the metal, which is calcium, then the name of the non-metal, but we need to change the ending by "ide", chloride. Then the name of this compound will be calcium chloride. In the table 9.1 of the textbook, there is a list of the representative positive and negative ions that have just 1 charge, except for hydrogen. We can see all the positive ions are metal, and all these positive ions belong to the metals group. And this happened because metals belongs to the groups 1, 2, 3 mainly. That's 1, 2, 3. This we know they are special. And then for them it's easier to lose electrons and become positive ions. But also we can see all the negative ions are non-metal, belong to the groups mainly 6 and 7. And they are negative because it's easier for them to gain electrons to be stable. You can find the same information in the periodic table that is in the equation sheet. And this is the periodic table that you will find in the equation sheet. And there is two ways you will know the charge for each ion. For example, for magnesium, if magnesium is in the second group, then for magnesium it's easier to lose 2 electrons and becomes positive 2 ion. But also, you will find the charge on top of the column, means all the elements in this column will be positive 2. All the elements in this column will be positive 3. All the elements in the column number 5 will be negative 3. And for example, all the elements in the column number 7 will be negative 1. Let's solve one more example. We will use electron dot notation to predict the formula of a compound formed when aluminum combines with fluorine. And let's see what is the compound that results if aluminum reacts with fluorine. And the first thing we need to check is how many electrons aluminum has in the outer shell. And we will check that in the periodic table that aluminum belongs to the third group, so aluminum has 3 electrons in the outermost shell. And then we will 1, 2, 3. The next thing we want to check is how many electrons fluorine has in the outer shell. When fluorine is in the group 7, so fluorine has 7 electrons in the outer shell. And let's go here. And then 1, 2, 3, 4, 5, 6, 7. Now let's see what happens if aluminum reacts with fluorine. Then if these two react, then aluminum will transfer 1 electron to fluorine. Now fluorine now has 8 electrons in the outermost shell. Fluorine is stable. But what happened with aluminum? Aluminum is not stable because aluminum has 2 more electrons that need to transfer. Then we need another fluorine. And we will do the same. 7. And now if these two react, then aluminum will transfer 1 electron to fluorine. Aluminum need to share 1 more electron because fluorine, the 2 fluorines, they are stable, but aluminum is not stable. Then we need 1 more fluorine here. Then now aluminum lose 3 electrons and each of these fluorine gain 1 electron. Then now aluminum is stable because aluminum lose 3 electrons and now aluminum has the neon electron configuration. And the fluorine gain 1 electron and fluorine has the neon configuration. Then both are stable. Then when these two react, what happens is aluminum becomes positive 3 ion and each fluorine becomes negative 1 ion. Then we can rewrite this one. We can rewrite this one like plus. We had 1, 2, 3, -1 ion of fluorine. Then we can write this one like that. Yes. Now we need to check if the new compound is neutral. Then in case of the positive ion, we had +3. And now here we had to multiply 3 minus 1, 3 ions of fluorine, each with -1 charge, then 3 minus 1 will be -3. Then we can see the new compound is neutral. Then now we can write the formula. Then first we will write the symbol of the metal or the positive ion, and then the symbol of the non-metal. And because we need 3 fluorines, then we will write here the subscript. And this is the formula for the compound that form with aluminum combines with fluorine. Also, we can write the name. And this will be the formula. Now the name of the compound will be first the name of the metal or the positive ion, which is aluminum, and then the name of the non-metal or the negative ion, but we change the ending by ide and will be fluoride. And this is the name of the compound. Then the name will be aluminum fluoride. Now let's talk about the transition metals. The transition metals are the elements that are in the D block or in the groups B. Some of the transition metals, they had just one charge, similarly to the elements in the groups A. For example, we had zinc, tungsten, silver, and cadmium. All of them are transition metals, but they had just one charge. But there are some elements in the transition metals that have more than one charge, as we can see in this part of the table. In general, the charge, or is called also the oxidation state of the transition metals, can vary from 1 to 7. The reason of this variation in charges in case of the transition metals is because they can lose electrons more easily than other elements, because they had unstable electrons in the outer shells. Because transition metals have more than one charge, we need to take into account it when we write the name of the ionic compound that involve transition metals. In this case, we will write the name of the metal first, but to indicate the charge of the transition metal, we will use a Roman number in parentheses. Then we will write the name of the non-metal, and as we did before, the ending of the non-metal material we will change by ID. We can see in table 9.6 how we can write the name of the metals ions that have multiple charges. For example, in case of the iron, to identify if the charge of the iron in the compound is +2 or +3, then we will write iron, and in parentheses we will indicate the charge. If the charge is 2, then we will use the Roman number 2. If the charge is 3, then we will indicate that using the Roman number 3. And we can see the same thing is for the other ions. Now let's write the name of this compound. To write the name of this compound, what we will do first is we want to write the equation for this compound. And because the compound involves iron and bromine, then we will write first iron plus bromine. Because we had 3 bromines, then we will write 3 here. The next thing is to write the charge of this ion. In case of the iron, we know the charge of the iron can be +2 or +3 because iron is a transition metal. And we don't know exactly what is the charge for iron up to now. And what to do is first we will check the charge of bromine. To check the charge, then what we do is we will see the periodic table. The periodic table, we can see bromine is in the 7A group, means the charge for bromine will be -1. Then we will write here -1. Remember, in order to get a compound, we need neutral compound. Then what in case of the negative ion, we will multiply 3 times -1, then we will have -3 charge. Means in order to get a neutral compound, we need here +3. So the charge of the iron must be +3 to get iron, bromine, 3. Now we can write the name of this compound because now we know what is the charge for iron in this case. Then we will write first the name of the metal, which is iron, and the charge in parentheses, and then the name of the non-metal, but we need to change the ending. Then will be then this will be the name of this compound, iron 3 bromide. And here it is more clearly. Now let's solve a few more problems. And in the first part, we want to name of the following compounds. First, we had lithium and fluorine, and then we had lead and fluorine also. And let's see what is the name of this compound and what is the name of this compound. And let's start with the part A. Always, if you want to write the name of any compound, I suggest you to write the equation. And in this case, we had lithium plus fluorine. The next step is you need to check the charge. And in this case, for lithium is in the group 1A, so it's +1 ion. Fluorine is in the group 7A, then the charge will be -1. Now we need to check if this compound is neutral. Then we had lithium is +1, fluorine is -1, then is neutral. And this will be resolved. And in this case, we will write the name of the metal first, which is lithium, or the element that has the positive charge will be lithium, and then the name of the non-metal, but we change the ending. Then will be lithium fluoride. And this is the answer. Now let's see the part B of the problem. And we want to write the name of this compound and of this one. Then first we need to write the equation, and because we had 2 fluorine, then we need to write here 2. The next thing is check the charge. Remember, lead is a transition metal, then we don't know exactly if the charge of the lead is +2 or +4. And what we had to do is first we will check what is the charge in case of the fluorine. And fluorine we know is -1. It's in the group 7. Now is in the group 7, then fluorine is -1. Then the total charge for the negative ion will be -2. In order to get a neutral compound, then lead must be +2. Then here we will have neutral compound, and we will get. And now we can write the name of this compound, then will be lead. Because it's a transition metal, we need to write the charge in parentheses to indicate the charge of the lead is 2, not 4. And then the name of the non-metal or the negative ion, but we change the ending. Then the name of the compound will be lead 2 fluoride. Now let's complete the part C and D of the example 9.7. In this case, we want to write the formulas of these two compounds, potassium bromide and copper 1 sulfide. Then let's see the part C. Potassium. Then in any case, I suggest you to write the equation. Then will be potassium and then for bromine. The next thing we want to check is the charge of each of these ions. Then in case of the potassium, potassium is in the first column, then is +1. Bromine is in the 7th column, so bromine is -1. Now we need to check if we had neutral compound. Then we had, on this side we have, this side we had +1, in the other side we had -1. Then we had neutral compound, then we will write first the symbol of the metal and then the symbol of the non-metal. And this is the formula for potassium bromide. Let's see the part number D. For part number D, we had copper. And because it's the Roman number inside the parentheses is 1, we know the charge for copper is +1. Then we know that. Plus sulfide. And in case of the sulfide, the charge is -2. Yes, belong to the column number 6, then is -2. And now let's see the charge. In case of the sulfur, we had -2. But we need neutral compound. Yes. Then in order to get neutral compound, we need to add 2 here. It's the only way we can get +2. And now let's write the formula. In order to get neutral compound, we need 2 ions of copper and 1 ion of sulfur. And this is the formula. Then in case of the potassium bromide, the formula is this one. And in case of the, let me write this one better. In case of the copper 1 sulfide, will be, this will be the formula. Now we are going to talk about the polyatomic ions. Polyatomic ions are a charged group of atoms that adds a single unit in an ionic compound. And here we had few examples of polyatomic ions, and we can see all this group of atoms, they add a single unit when we are trying to form ionic compound. Then this unit, for example, is the charge of all this unit is -1. In case of the chromate, for example, the charge of this group is -2. Now, how we can write the name of the ionic compounds that involve polyatomic ions? Then we will follow this rule. First, we will write the name of the metal and then the name of the polyatomic ion. If the metal is a transition metal, then we will use a Roman number in parentheses to indicate the charge. Also, in your equation sheet, you will find the list of the common polyatomic ions. Then let's write the name of these ionic compounds that involve polyatomic ions. Remember to write the name, we write first the metal and then the name of the polyatomic ion. And in this case, we had sodium, and we will check in this list what is the name of this polyatomic ion, and we can see it's hydroxide. Then the name of this will be sodium hydroxide. Let's see what is the name for the second ionic compound. And we had potassium first, and then we had hydroxide. Then the name of this compound will be potassium hydroxide. For the third one, we had sodium, and then we will see what is the name of this polyatomic ion. Then we had here, and in this case will be nitrite. Then the name of this compound will be sodium nitrite. Let's see for this one. We had sodium, and let's see what is the name of this polyatomic ion is carbonate. Then the name of this compound will be sodium carbonate. Let's see the last one. We had calcium, and then we will see what is the name for this polyatomic ion, and is here will be nitrate. Then will be calcium nitrate. And this is the name for each of these compounds. Let's see how to write the formula of the ionic compounds that involve polyatomic ions. Then let's write the formula for these three compounds. Let's start with the first one. First one is lead 2 nitrate. Then first we will write the equation. And we know it's lead 2. Then we know that the charge for lead is 2. And it's a metal, it's a positive ion. Always the positive ion is the first. Plus nitrate, then we will see here what is the charge for nitrate. Then it's -1. Then we will write here. The next thing we want to check is if the compound is neutral. And in case of the positive ion, we have +2. In case of the negative ion, we have -2. Then we need neutral compound. Then we need to multiply here by 2 in order to get here 2 minus 1 minus 2. Then now we have neutral compound, and now we can write the formula. First, symbol of the metal, and then the polyatomic ion formula, and then because we need 2 molecules of nitrate, then we will write here 2. And this is the formula for lead 2 nitrate. And let's solve the second problem. In this case, we have potassium chromate. And potassium plus, then let's see, chromate is -2. Let's write this one better. This one is -2. And now we need to check what is the charge in case of potassium. We know potassium is in the first group, so potassium is +1. And we can write here +1. Now the next step is check if we had neutral compound. Then in case of the negative ion, we had -2. But in case of the positive ion, we had +1. We need +2. Then to get +2, we need to multiply potassium by 2. We need 2 potassium, as in that case. Then 2 times 1 is +2. And in order to form the compound, we need 2 ions of potassium. Then now we can write the formula. We had neutral compound, we can write the formula. Then we need 2 ions of potassium, and this is, we will write here the subscript, and then we will write the formula for polyatomic ion. Then this is the formula for the ionic compound for potassium chromate. Let's solve the third problem. And in this case, we had aluminum acetate. And aluminum plus, and then we will see what is the charge for acetate. And we can see it's -1. And then we can write the formula for acetate will be -1. Now the next thing is we need to check what is the charge in case of the aluminum. Then aluminum is in the third group, and this is why aluminum is +3. Then we will write here +3. Now the next thing we want to check see if we had neutral compound. And here we had +3. In case of the positive ion, we had +3. But in case of the polyatomic ion, we had -1. Then to get neutral compound with 3 units of 3 molecules of acetate. Now 3 times -1, we had -3. Now we had neutral compound. Now we can write the formula. Then we need 1 ion of aluminum, and we need 3 molecules of the acetate. Then we had here. And this subscript indicates we need 3 molecules of acetate. Also, you can write this equation. You multiply this 2 times 3, and then you will get 6. 3 times 3 is 9. 2 times 3 is 6. And sometimes the formula is like that. Both are correct. Let's solve the last problem. Let's start with the part 8. And we want to know the name of this compound. What I suggest you is always to write the equation, just to make sure you had the neutral compound and you had the correct charges. And let's see, start with the 8. We had sodium plus sulfate. And let's check what is the charge for sulfate. In case of sulfate, we had -2. In case of sodium, we know sodium is +1 because it's in the first column. And we had sodium is +1. In order to get neutral compound, we need 2 ions of sodium because we had here -2, and this is, in order to get +2, we need 2 ions of hydrogen. And this is why the formula is this one. Yes. You can use parentheses if you want, just to indicate this is one group. Then the name of this compound will be the name of the metal, which is sodium, and then the name of the polyatomic ion. And we can write here is sodium, and then the name of the polyatomic ion, which is sulfate. And the name is sodium sulfate. Now let's try to solve the part B. In this case, we want to write the equation. Then we had copper plus, and then we had hydroxide, which is a polyatomic ion. And the next thing is we want to know the charge for each of these ions. And in case of copper, because copper is a transition metal, and we don't know what is the charge. It can be +1 or can be +2. And we don't know exactly what charge. Then let's see what is the charge for the negative ion, for hydroxide. And hydroxide, we can check in the table, is -1. And here is important, we had 2 molecules of hydroxide. Then we need to write this one in the equation. Then the total charge for the negative ion will be 2 minus 2 will be -2. In order to get a neutral compound, then copper must be +2. And now we have neutral compound, and now we can write the formula, which we know. And now we can write the name. Then will be the name of the metal, but here because it's transition metal, then we need to write what is the charge. To indicate the charge, we will use Roman number. Then let's write copper, and we will indicate this, the charge is +2 using the Roman number, and then the name of the polyatomic ion, which is hydroxide. Let's see the part C. And in this case, we want to write the formula of the calcium carbonate. And let's write the equation, calcium plus, and then we need to write carbonate. And carbonate is CO3, and this is -2. Now, what is the charge of calcium? To know, we will use the periodic table. Then calcium is in the second group. This is why calcium is +2. Calcium is +2. Now we need to check now if we have neutral compound. Then we had +2, we had -2, then it's neutral. And to write the formula, we just write first the metal and then the polyatomic ion. Can be like that, or you can use also parentheses. You can write like that. Both are correct. Let's see the part D. We want to write the formula for calcium phosphate. And in this case, we had calcium plus, and then we have phosphate. And phosphate is PO4, and the charge is -3. Now let's see what is the charge for calcium. For calcium, we had +2 because it's in the calcium is in the second group. and will be positive 2. Now the next thing we need to check if we had neutral compound. And we can see in this case it's not easier to multiply for one number or another number. There is two ways we can complete the problem. One is you can use the crossover technique. It's just you will multiply calcium, the calcium you will multiply by the charge of the phosphate. This is one way we can do. Then you can multiply this one by 3, and then you can multiply the phosphate by the charge of calcium. And this is the crossover technique, and you will see you multiply 3 times 2 will be positive 6, and 2 times negative 3 is negative 6. Then now you had a neutral charge. Then now you can write then you will need to form calcium phosphate. You will need 3 ions of calcium and 2 molecules of phosphate. And this is the formula for this compound. The other way you can find the number you need for what number you need to multiply each of these ions is using the least common multiple. And the least common multiple between 3 and 2 is 6. Then for what number I need to multiply 2 to get 6 will be 3. For what number I need to multiply 3 to get 6 will be 2. And also this is another way. Then you can use either way to solve the problem. And this is all I had to discuss for today.